Okay, so today we start, or today we do the concept of net force. We did net force in grade 11, but the major difference between net force in grade 11 and net force in grade 12 is that this time in grade 11 we did not do any angles. In grade 12, obviously, we have to incorporate angles. So whenever more than one force acts on an object, a not so new quantity must be defined. So if there is exactly one force acting on an object, you do not need the concept of net force, because that exact one force becomes just the net force or the overall force on the problem. Sorry, on the object. If you got more than one, then you actually might have to what? Have to consider the idea of a net force. Okay? So this quantity is simply called the net force. What does the word net mean, by the way? Not in a description, just in a maybe what's another word for net? Like when you talk about your net income, what are you talking about? Okay, total could be one way of saying it. Another way, hmm, when you calculate your net income, usually what do you do? Like what things do you incorporate in it? Net income. Once you have a job and you start, collecting money, when you want to collect your net, sorry, calculate your net income. Okay, so some things are going in, but some things are also what? Exactly. So when you say net, you also can say what? Overall, right? Or the combined effect of everything. Okay. So the net force, in simplest term, is the overall force that combines the effect of all the forces acting on the object. This is important. From the outside, we never care, you never care in any physics analysis about internal forces, unless you're actually studying the what? The internal structure of an object. But if you're just studying its kinematics and its forces, or its dynamics, as they say, you only care about what's acting on the object from the outside. From the outside. That's why I always tell you, you can sketch any object in FPD as just a what? As just a what? A dot or a box, which means does the inside of it matter? No, it doesn't. And that's another reason, because it only matters the external effects on it. Okay? By the way, what affects an object's motion is purely the external forces acting on it, not the internal forces. Okay? Since forces are vectors by nature, and that's why I asked you what happens when you calculate your net income. Some things are going in, some things have to be coming out, which means the signs of the forces or the directions of the forces do matter for sure. Okay? The biggest mistake people do when they do what? Net force, is they only combine the what? The magnitudes. Completely incorrect. Why? Because then everything just gets out to be what? To be positive, which doesn't always have to be. For example, okay, Ammar, pull on this. Yeah, pull, pull. No, no, don't, not too much. Okay, pull. Is it moving? Okay, but are we both pulling? But are we pulling in the same direction? So technically, what is the net force on this if it's not moving? Zero. There you go. If we just added our magnitudes, would we ever get zero? No, we wouldn't. But if we added the magnitudes with a plus for me and a minus for you, then would we get zero? That's the whole idea. Directions matter. And that's why you need to understand that pluses and minuses here are super important. Okay? All right. Okay. This is not to copy. This is already the whole slide is in your handout. So a very important a very important warning here. The following two statements are not the same. You saying the net force on an object is zero is not the same as saying what? The forces on the object are zero. What's the difference? Without looking at the note, you already have the explanation. But what could you think the difference between these two statements are? How come they are not meaning the same identical implication? Ahmed. Uh-huh. Like 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 me and Ammar, right? You know, like we will put on the water ball. How about the next one? Yeah, exactly. All the forces have completely what? Vanished, not canceled, vanished, and all of them have a magnitude of what? Where could this physically happen? Only in what? In deep space where there's no gravity, no friction, absolutely nothing. How about the first one? Do you need the deep space for the first one to be realized? Nope. As long as everything what? Cancels out to be 0, then the first statement is correct. The first statement says that all the external forces on object have been combined, which means they had to exist first, and they canceled each other out to be 0. In other words, the overall collective effect of all the forces is just 0. The second statement means every force began with being itself 0, which means in other words, you did not have any forces to begin with. So the second statement, there is no combining forces here because there are none that exist. What are you going to combine? Theoretically, deep space. Okay, so always know that net force and force are not the same thing. They are related, but they're not the same thing. Forces need to be combined for you to get net force. Okay, so let's do a very a basic demo at the beginning. So let's do this one. I apologize for the resolution of the picture. So at an instant when a soccer ball is slightly off the ground, what do you think they're saying? Why do you think they're saying slightly off the ground? Hint, there is no contact between the ball and the ground. What does that mean? What? So exact. So two forces cannot exist. What's the first one? Friction. What's the other force? Considering the Earth is a surface. Normal force, exactly. So this ball right here has no friction on it and has no normal force on it. Okay, a player kicks it, exerting. How many people know what the word exert means? They love that word in physics. They use it in place of another word. I will use the other word, which is easier more, but you will always see this in any physics textbook. Apply, yes, thank you. Whenever you exert a force, you really apply a force. So exerting a force of 25 newtons at what angle? 40 degrees what? So 0, 40, and then you kick, right? The force of gravity acting on the ball is how much? 4.2 newtons, because it's Fg, and going straight what? What is the net force at that kicking moment on the ball? Okay, what do I need to sketch? I have one object of interest. What do I need? A soccer ball at the center of what? An FBD. All right, so let's sketch the FBD. How could we sketch this FBD? Well, I guess a side view would be the best one. So here is the ball. That's not a ball, but whatever. Okay. Now, what's the first force on it? Always gravity. Unless you're told gravity doesn't exist, you have to put gravity on the shape first, or on the diagram first. Okay. Go ahead, FG like this. By the way, you can put Fg equals 4.2 newtons. I'm not a big fan really of putting numbers on the diagram. I'd rather do symbols because, by the way, in first year physics, many of your problems are not going to have any numbers in them. In fact, they want you to do a symbolic derivation of the whole thing. Okay, how am I going to sketch the other one? I know its magnitude and I know its direction, but how am I going to put that on the diagram? Yes, exactly. So I'm going to imagine what? A horizontal line for the line of sight, like here. Let's say it was kicked this way. Sorry, I mean that's the line of sight. And then I'm going to go 40 degrees above the horizontal, which means from the horizontal, I'm going to go 40 up. So something like this. That's it. And obviously this will be what? Force applied, F-A-P-P. And this would be what? 40 degrees. Oops, sorry, 40. Done. That's it. We said no friction. We said no normal. And obviously there's no tension because there's no ropes or strings attached to this. Okay, I need to add these two forces. What method did we say we're always going to follow from now on? Vector decomposition, not cosine sine law. Okay, so let's do this as a what? As a vector decomposition. All right, so just to quickly, put everything on a grid. This is my y. By the way, why can't I call this north, south, west, east? Why am I choosing to call it y and x? Say again? They did not give us a direction, but what's another reason as well? What does it? How are north, west, east, and south always directed or oriented? Does north mean up? North is what? Is north a physical direction or a geographical direction? So does it point this way or away from you this way? Exactly. North, east, west, south point on a what? On a plane. But up and down point what? Straight up and straight down. So this problem has nothing to do with what? Geographical direction. It has to do with up, down, forward, backward. That's it. Okay. So here's my FG. And here's my FF. And here's my 40. How many good vectors do I have here? I have 2 vectors in total. How many good vectors do we have? How many bad vectors then? All right. Which one needs to be broken down? For the 40-degree one, basically the tilted one. Okay, let's break it down. This way and this way. Which one do you think we should choose as positive direction? X or the other X? Yeah, there are no vectors this way, which means there's no point in putting positive here. So everyone go ahead and put positive right here. Oh, sorry. How about the y-axis? Do you think we should put uh, positive up or down? Remember, it doesn't matter. Never matters. As long as you can explain your answer at the end, depending on the sign you chose. But what do you think we should choose? Let's choose up. Let's choose up. Why? I have a feeling that the up force is gonna what? Win compared to the what? Compared to the downward force. Okay, so let's put just up here. Okay, all right. By the way, all this should be right here under the diagram. You should have enough space for it. Our mathematical analysis will be where? Will be here on the blank slide. Okay. Which axis has fewer forces on it? Fewer arrows on it. The X, it only has one. This one has how many? 2. So let's start with what? Let's start with the X-axis analysis. All right. Can you tell me if this component right here, everyone, can you tell me if this component is a cosine or a sine? And you have to tell me why. This is the inner dialogue that you always have to have yourself once you get to do these breakdowns. Josh, why? Exactly. This component is adjacent to the what? To the 40-degree, which means it has to be what? Cosine. Which then leaves this one to be what? Without even any more work, because if one is cosine, the other one is the other twin. All right. So let's start. All right. X-axis. F net equals. Okay. Was it pointing positive or negative? Come on. Was it positive? So you just put a positive. F applied. And as Josh said, cosine of 40. All right. Equals. What was the magnitude of the force? 25 newtons. 25 newtons. Obviously, no need for newtons. You just keep the units until the end. That's it. So how much horizontal force was it given? I don't know. 25 times. Oh, actually, let me do the cosine first. 40 trig cosine times 25. Okay. What's the significant situation here? 2 for the force, 3 for the what? 3 for the angle. So 2. But is this my final answer or not yet? Not yet. So let's keep what? Let's keep 3 sig fig. How would this be to 3 sig fig? 19.2. Go ahead. 19.2 Newton. Okay. That takes care of what? That takes care of the x-axis. Let's do the y-axis. All right. Y-axis. Okay. F net. Oh, everyone. I mean, okay. My bad. Technically, the fact that you said x-axis, do you need to say f net x here? You don't. But probably, you know what? Let's get used to this habit. So you don't have to say x-axis and y-axis every time. You can just start by telling me with a subscript which one it is, and then you don't have to tell me that. So f net y. Okay. What's the situation with the F net on the Y? And I'm just going to zoom out so you can see. This one gets what? This one gets, and this one obviously gets what? Negative. So we have a plus and a minus. Okay? So plus F app sine of 40. Subtract how much? How much is FG full? 4.2 with no breakdown. 4.2. Okay, we just got to write FG for now to keep it in consistent symbols. All right, let's do this. 25 sine of 40 minus 4.2, which is equal to, let's do it in one shot. Sine of 40. So 40 trig sine times 25. Subtract 4.2. Yep, I told you. The upper one is going to win. That's why our answer came out to what? Came out to be positive, because we chose positive to point up. All right, what is this to 3 sig figs? That. 11.86 becomes 11.9. Yep, 11.9. Okay, once you have the F net on the X and F net on the Y, or once you have X and Y, what do you always do? 2 steps always after. Every time. In grade 12 and first year. What do you do once you have the X and the Y? You do Pythagorean, and then you do what? The tan inverse to find the theta. That's it. So let's do Pythagorean. By the way, Pythagorean, you don't have to say c squared equals. You can just start by saying this. F net equals square root, and you can square this guy and square this guy and add and square root. So 19.2 squared plus 11.9 squared. All right. I don't know how much that is. I just know it's in Newton. All right. Clear. 19.2 squared plus 11.9 squared equals, and then you square root this guy. What is this to 2 sig figs now? 2 sig figs, because this is my final answer. 22.5 will be crossing to what? To 23. So the answer is 23 Newton. All right. How about the angle? Theta equals tan inverse of. If you always want to give me the horizontal angle, what do you always divide by what? All the time. You always divide the y component by the x component. If you always want to give me the horizontal angle, you always divide the y component by the x component, which means here it will be 11.9 dividing by 19.2, which is, I don't know what that is, 11.9 divided by 19.2. Trig, what do I need to use? I need to use tan inverse, which means I have to hit second to get the inverse functions, and then I hit this guy. My angle, again, what is it to 2 sig figs? 32 degrees. The book uses what? Uses the, one second. The book actually sometimes uses like a different sig fig for the what? For the angle than the what? Than the magnitude. However, technically, since the angle was incorporated into the what? Into all the calculations, all of them should be subject to the what? To the same sig fig situation, which is what here? 2. So it is 32. Done. That's it. Therefore statement, if you want to do it, it has to look like this. F net as a vector equals 23 newtons. Now, do we have north, east, west, south here? No, we don't. We have what? X and Y, X like forward, backward, upward, downward. However, my angle was what? Above the horizontal or below? Above. So you, by the way, you can definitely just say 32 degrees above H. Seriously, whenever you do forces, you can either, as long as the problem is not what? Northwest, east, south. you can just say the angle is directed above H or below H. That's it. Done. H means horizontal. Okay, everyone. Now, what instead, listen up. This is going to be now a reverse problem. Instead of giving you how many forces, if it's giving how many? 3, and asking you for the net force, no. Now I'm asking you, I'm going to give you how many? 2, and I'm going to ask you what third force should be there to cancel the whole thing. Okay, so think about it. We still have how many forces? 3, but how many of them do you know now? 2, and how many don't you know? How many do you need to know? 1, such that it what? Cancels. When you cancel, when all the forces are canceled, what's the net force? There you go. So now, instead of having 3 forces and calculating F net, no, I'm giving you 2 forces. I'm giving you F net of what? 0, and I'm asking you to find the third force. So let's say, for example, I gave you FA and FB, and I want you to find what? Such that it kills the effect of what? FB and FA, okay? It neutralizes them, all right? Okay, so let's just look at the problem. Okay, so given FA is 33 newtons in the east 22 north direction, and FB is 42 newtons in the south 15 east direction, calculate the force FC needed so that FA as a vector plus FB as a vector plus FC as a vector is equal to what? So that means I want you to write here F net equal 0. By the way, just so you know, if you write this statement in Mr. Shiver's class when you do vectors, he's going to take a mark off. Can you guess why? Look at the left side and look at the right side. What's the difference between the left side and the right side? There's no what? Yes, you can never make a vector equal to just a what? What's the opposite of a vector? Scalar. You can never make a vector equal to a scalar. You better make this one also a what? Yeah, it's called the 0 vector, which is still what? Which is still the 0. Okay, but you still need to make it what? Of the same nature. I'm just saying. Okay. If you go to science or engineering and you do a course called linear algebra, which is basically all about vectors and lines and planes, this statement written in the wrong way, like without an arrow on top of the 0, is completely incorrect and actually could ruin the calculation. So always remember, vector is always equal to a vector. Okay, all right. So you already have the grid. So let's start. How many vectors do I know? I know 2 vectors. I know the FA and the FB. Okay, let's start by putting them on. Go ahead, everyone. This is the FA. By the way, I'm going to teach you 2 methods for this today. The first method is going to be longer and more mathematical, but you still need to know it. The other method is going to be quicker and more interesting. But I just want to show you both. All right. So is this a good or a bad vector? Bad, because it needs to be broken down or decomposed. Okay. Did I show the decomposition? Not yet? Okay, no problem. Come on. Okay. All right. Go ahead, everyone. Come on. FA points this way, and it's short because FA is how long? How long is FA? 33 newtons. Everyone, FA is 33 newtons. And the other one is 42 newtons. Where do you think I should place FC? Everyone, how should you pull to cancel the effect of those 2? Question, can you pull this way? Why can you not pull, everyone, why can you not pull this way and cancel everything? Because then everything is pulling to which way? To the east or to the right. So that doesn't work. Same thing. How about here? No, because then still everything is pulling to the what? Pulling to the east, to the right. So those 2 are bad ones. Okay? So definitely, if you're going to pull to cancel these, which way should you pull? You definitely should pull either this way or this way. Okay, let's randomly say we're going to pull this way. So everyone go ahead and make FC that way. Oh, let me show you the, yes, go ahead. Go ahead, come on. Okay, okay, you have a question? Go ahead. You sure? Remember, all I did here, listen up, was randomly choose the quadrant. I did not randomly choose the side. I randomly chose the quadrant. I said, I'm going to put it here. I neither know the magnitude nor the what? Fine. Yeah, we don't know either. I don't know the I don't know the force, which means I don't know two things about it. Okay, that's fine. Now, which direction do you think should be positive, east or west? Okay, which direction should be positive, north or south? Okay, I'll give you a hint. Because everything is canceling to what? To zero, it doesn't matter. Okay, remember, when things are canceling to zero, it really never matters east or west, north or south. Do you know why? Because nobody wins, right? When things cancel to zero, who's winning? No one, which means it doesn't really matter which one is positive and which one is negative. I have a preference that whenever nothing matters, I go back to math. Which one is positive in math? Right or left? Right. And how about up and down? Up. That's it. So we will choose. Let me see if I. Oh, okay, I'll go back. So we will choose this one. Oh, I need the pen. We will choose this to be positive and this to be positive, which means this to be negative and this to be negative. Okay. All right. What do I do now? I start with the FNet calculation on the X and the FNet calculation on the Y. All right. Let's do this. Who's still copying the diagram? Everyone's good? Okay. So let's start with the math. So let me exit this slideshow. Okay. Microsoft Paint. Okay. Before we do that, let's look at the diagram, everyone. How many forces do I have on the x-axis? Come on. How many forces do I have on the x-axis? I have three, two known and one unknown, but in total three. How many of them are positive? And how many of them are negative? But everything is adding to what? Good. Okay, let's start. So x-axis. X-axis. F net on the x equal positive, positive, negative. Okay. Which ones are pointing positive? A or B or C? Just the forces. Don't tell me the angles yet. Just A and B. So FA, FA, FB, and FC is the one pointing negative. Okay. Cosines or sine? Let's look at the diagram. Everyone focus with me here. Everyone, for FA, pencils down, pencils down. For FA, this is the component, right? Is this cosine or sine of 22? How many people say it's a cosine of 22? That is correct. This component right here is adjacent to 22. Adjacent is cosine. All right. Okay. How about this one? Just 1 second. Let me just show it. Uh-huh. This one. It's as big as this one, which is what? It's opposite to 15. That's how you always do it. Take your time, one by one. So this is sine of 15. Okay. How about this one? Cosine because it's what? Because it's adjacent. Perfect. How much is F net on the whole thing? The whole problem has how much F net? 0, which means it's 0 on the x and 0 on the y. Great. 0 equals FA was 22. How much is FA? Magnitude. 20. Sorry, how much? 33. 33. Cosine of 22. Come on, just copy with me. Mine plus. How much is FB? 42. Sine of 15. Thank you. Minus FC cosine of theta. Okay, what do you think is my next step now? Any more physics, or is it just math now? It's just pure math. All right. Let's obviously, I cannot do anything with this. Everyone, I cannot do anything with this. But I definitely can clean this up in one shot. So I'll do it for you right now. And you can do it yourself to check my answer. 33, what is it? 33 cosine plus 42 sine. So I need to put cosine first. Okay, hold on. Let me see how we're going to do it. 22 cosine times 33 plus, what was the next angle? 15 sine times 42. Yes. Cosine of 22 times 33 plus sine of 15 times 42 equals that. 42, 47. Sorry, 41, 47. Sorry? Should I write? Oh, no, no. Keep doing this till the end. How many unknowns do you have in that equation? Everyone, how many unknowns do you have in that equation? FC and the cosine of theta or just the theta. Can you solve one equation in two unknowns? No, you can't. What do I still need to do now? The exact same amount of work, but for what? For the F net on the Y. Go. Y axis. F net on the Y. How should I change this? Come on, everyone. Wake up. Only 5 minutes, and then we're done. How should I change this? First of all, every cosine should switch to what? Sine. And every sine should switch to what? Cosine. But how about the signs as well? Like the pluses and minuses. Which ones here are pointing up? Which ones are pointing up? Apparently the FA and the FC. And which one is pointing down? FB. So I have two pluses and one minus. It's just my habit. So plus, plus, minus. Plus, plus, minus. The first plus is an FA. The second plus is an FC. The third, the minus is an FB. Okay. I don't even need to look at the diagram anymore. I just look at these and do what with the trigs? Switch them. Whatever is sine, cosine. Done. All right. A used to be cosine, so now it's sine. C used to be cosine, so now it's sine. B used to be sine, now it's cosine. Okay, let's put the numbers in. FA was 33 sine of 22 plus unknown, unknown, minus FB, which is 42 sine of, sorry, my bad, cosine of 50. Equals. Okay, what do I need to add now? I need to, well, not add. I need to subtract this guy minus this guy. All right, let's do this. Give me 1 second. All right, what do we do? 33 sine minus 42 cosine. Okay, clear, clear. So 33 sine. So 22 sine times 33 minus 15 cosine first times 42. Let me check. Sine 22 times 33 minus cosine. Yeah, that's correct. I got a what answer? That's fine. That is fine. Trust me, it's not going to matter. But it should be negative 28.21 because the 0, 6 will become 1. So, oh, 0 here, sorry. 0 also here. So negative 28. What did we say? 28 to 1 plus. Okay. If you can, everyone, box this one and this one. Okay. By the way, I'm teaching you a lot of grade 12 math in a pure physics problem. And I realize why so many people are feeling brain fried right now, but we're almost done. How many equations do I have? How many unknowns do I have? Can we do a 2 for 2 system? You can always do a 2 for 2, 3 for 3, 4 for 4, 10 for 10 for 10. As long as you have as many equations as variables, you're fine. But the question is, how should I do this? Compare them. You can. By the way, there are so many ways to do this. Here's my preferred way. First thing, I'm gonna move this guy where? I'm gonna move the minus FC cosine theta where? To the other side. So how many things happen? 2 things happen. This minus becomes a what? Always good. And my variables go to which side? Go to which side? The left side, right? Which is always natural for variables. Okay. Now, do I need to move this? Or I'd rather move this? Yes, which then you can switch. So, everyone, the first equation has got to be this. Let me just do another. Hold on 1 second. Okay, so equation number 1, everyone. F, what was it? What would it be? FC cosine theta equals FC, yep, FC cosine theta equals 41.47. How about the next one? FC sine theta equals what? 28. No, not negative. Because remember, I moved and then switched. Everyone, look, just a very quick recap. I moved this one here, so it became what? And then because I don't like the number to be on the right side, left side, I just what? I just switched, right? If A is equal to B, then B is equal to what? Then B is equal to A. I just switched the side. Okay? Yes, exactly. Instead of 6 equals 6, not good. We just write x equals 6. That's exactly what I just did. Hold on, one second. I know you're seeing something here. Just 1 second. But that makes sense, Ken. Okay. If you write this at the end of a math equation, technically, are you correct? Technically. Yeah, but do you think you're going to get full mark? No. So what should you do? You should write it as what? X equals 6, right? Now, obviously, the long way of showing this is move this here, which will mean what? Minus x equals minus 6, which is equivalent to saying what? Does that make sense now? This is exactly what I did here. I moved this guy here, getting to this step. And then, since I can just switch sides, I skip that step to this. Does that make sense now? All right, you can always do that. Why go through 2 when you can just go immediately from that to that? Yes. Now, Josh, are you telling me how to approach this? Oh, sorry. It is. It is. But trust. But actually, this happens to be the only way to do a problem in energy and momentum. So that's why I'm already building up to it. You will see that. Trust me. I've been doing this for 12 years. There is method to madness. And this is the way they actually want you to do it in first year physics. Can someone tell me how to solve that? Okay, I'll give you a hint. Sine and cosine are the parents. If you divide sine by cosine, what do you get? You get what? You get tan. And that's exactly what we're going to do now. We're going to divide this equation By what? By this equation. So dividing, let's call this equation 1, and let's use Roman numerals like they do in substitution and elimination. So divide 2 by 1, like whichever one has the sign by the cosine. Check this out, everyone. Something very interesting is going to happen. And Josh, you're right. This is overly complicated, but I always show you the long way before I show you the shortcut. So FC sine is 28.21 divided by 41.47. Can someone tell me what's going to happen now to the FCs? To the FCs. The FCs are going to cancel out. Beautiful. Cancel, cancel. And the sine over cosine generates a what? So we just created a 10. So 28, 21 divided by 41, 47. 0.6802. And what do I do now? This is not my angle. This is the tan of my angle. So what do I do now? Inverse tan. Which is what? I don't know. I'm going to trig second tan. Boom. 34.2 degrees. That's only the angle. How am I going to find the FC? Come on, everyone. Think math. You already found one of the unknowns. How do you find the other unknown? Okay, I'll give you a hint. How did you do it in substitution and elimination in grade 10? When you found the x, how did you find the y? You substituted back into one of the two equations. Great. I have two for a reason, because now I can pick and choose. Doesn't matter which one you choose? Absolutely not. You can use both only to check. But trust me, you never need to use both. You can use both. You don't need to. So my final answer now is FC equals, which one, Dana, which one do you want to use? Equation 1 or equation 2? Doesn't matter. They have to produce the exact same answer within rounding error. Equation 2. All right. So that means what? It's got to be 2821 divided by what? Divided by sine, because I'm trying to isolate for the FC. So 28, come on, what? 821 divided by sine of what? Well, I don't need to call it theta anymore because it's already what? 34.2 degrees equals, where is it? So I'm going to divide first, or sorry, sine first, 34.2, trig sine, and then I'm going to flip it. This is my way of doing it. Flipping it and then multiplying it by 28 to 1. Trust me, you got to get the same thing if you just do the math. Boom. That's how much force you should be pulling on the other side with. 50.2 newtons. Done. By the way, in such a statement, you didn't need to give me a what? You didn't need to give me a therefore statement. You know why? You've already shown me a diagram. You already showed me what angle is it and how much force there is. Okay. Can anyone think of an easier, quicker method other than Josh? No, you're fine. I'm just interested. Think, everyone. You are trying to cancel two people. How should you do that? Pencils down. Don't type anything. Josh, what's your other method? Everyone, listen up. This is much easier. Come on, guys. Everyone, eyes on the screen. Josh, go. You don't need to do that. What do you need to do? Or what could you do? But you need to, because according to the angle, if you do not pull exactly at 34.2 degrees, we still put at 50, you're not going to cancel the whole thing. You need to put sine and cosine. because you need to incorporate the angling of the what? Of the force. Okay, everyone, here's my other method. We will discuss what you just said. Check this one out, everyone. Look, forget that you have FC. Finish the what? What's that word? Which is the what? The resultant of these two forces. And then what? Flip it. Do you see what I mean? Instead of two people here, just compress them to how many? One person. And then what do you do to that one person? Basically, those two people make this one person. Just flip. I know, but then I wouldn't have been able to show you so much math that is needed for your grade 12. Okay? Boom. Done. Okay, yes. Sorry. Okay? So again, if I ever give you a cancellation problem, obviously I encourage you to do it that way, of course. Or if you want to do it the other way, completely up to you.